Okay, welcome back. This is day 2's lecture. We're going to learn about data structures. Specifically, we'll learn about vectors, matrices, and arrays. Okay, so first let's review a data set. So recall data sets are rectangular arrays of data. Columns are variables, and rows are the elements or the experimental units. So the rows are indexed by I, columns are indexed by j usually. So specifically the ijth entry is the value of the jth variable for the ith experimental unit. The value that the variable takes on determines whether it's categorical, and remember categorical variables can be ordinal, so ordered or nominal, or variables can be continuous. It's important to understand a bit about different structures. So different structures are used for different types of variables. So just before we jump into vectors, let's read about a few data sets. So here's the MT cars data set, and you'll notice it tells you this is a data frame with 32 observations on 11 numeric variables. So we don't know what a data frame is yet, but we will learn soon enough. So you can read a little bit more about this stuff. But you'll notice we have the first variable is miles per gallon. The second variable is number of cylinders. The third variable is displacement. Fourth variable is horsepower, and so on. And then we have whether or not our engine is V-shaped or straight, automatic or manual transmission, so some categorical variables that are coded as 0 or 1 here. Okay, if we print out the car's data set to the console, this is what it looks like. So here, Mazda RX-4, that is unit 1. The variable, miles per gallon, cylinder, displacement, and so on, those are our variables. So if we look at the first row, second column, that's the number 6. So that means the Mazda RX-4 had 6 cylinders. Okay, some more notes. All objects have one and only one storage mode. This can be numerical, character, or logical. All objects can have one or more classes assigned to it. The class of an object is going to tells the functions what to do when applied. So when you apply a function like mean, it'll go and read what is the class of the object to know how to apply the mean function. So in some cases, mean can't be computed. So you can't take the mean of a categorical variable. R will know that based on the class of the variable. Okay, so that's general overview of data sets and structures. Now let's jump into some more concrete examples. Let's talk about vectors. So elements of vectors have mode and class numerical, character, or logical. So in this case, the class and the mode are the same. All elements must belong to the same mode and class. So here's how we'll create a vector. We've already seen this a little bit. So we'll use this C that stands for concatenate, and then we enter our elements one at a time, separated by a comma. And then if we run my vector, if we want to pick off the ith element, we can refer to it by plugging in the number of the element that we want to find or print to the screen. So what you should always do is first read the help file for any function. So this is a generic function which combines its arguments. So it can actually be used much more generally than we will use in this class. But for this, I think it's the best way to learn this is just to run some code. So here I've created a vector using the concatenate function. The first element is 1, and then I have elements 2, 3, 4, 5. That's what the colon stands for. And then I've tacked on the element 3 at the end. So now if I print A to the console, you'll notice I have 1, the numbers 2 through 5, and then the number 3. So this 1, 2, 3, 4, 5, 6, this is a vector with 6 elements, and these are the elements. Here's another vector with 6 elements, and in this case the elements are 1, 2, 3, 4, 5, 6. Notice if I take this vector minus this vector, it does the subtraction element-wise. So it takes 1 minus 1, 2 minus 2, 3 minus 3, and so on. 3 minus 6 gives me negative 3. Likewise, if I add 1 through 6 to the vector A, it does the addition element-wise. 1 plus 1 is 2, 2 plus 2 is 4, and so on. Likewise, if I do A divided by 1 through 6, it takes this guy, 1 divided by 1, 2 divided by 2, and so on. 3 divided by 6 is the last element. So operations, basic math operations are done element-wise unless you tell R otherwise. I can even take A squared, that's going to square each element, 1 squared, 2 squared, 3 squared, and so on. I can take e to the a, so 2.718282 to the first power is itself. To the second power gives me 7.389, and so on. If I take log of 1 is 0, log of 4 is 0.693, and so on. Something you might want to do is to round your answers or prints out a lot of decimals. And how you can do that is round your answers to 2 decimal places using this 2. And there are other ways for cleaning up how R will print data to the console. We'll talk about those later. A minus 2, what's this doing? The minus 2 says go find the vector A and remove the second element. So if we recall what A is, here's A minus 2 removes the second element. If I do A of 2, it gets the second element, and so on. If I do A of 2 through 3, it gets the second and third element. Okay. The mode of A is numeric for this vector. The class of A is also numeric. And if I type str, str stands for structure. So again, I would encourage you to read the help files for mode, class, and structure. So structure of A tells us that this is a numeric vector with 6 elements, and the elements are 1, 2, 3, 4, 5, 3. Let's look at a different vector. So here I've created the vector, and notice I put in quotes 1, 2, 3. So these are not the numbers 1, 2, 3. These are now characters. 1, 2, 3 in quotes. So I can't do any arithmetic to these guys. And if I run mode of B, it tells me this is a character vector. And it belongs to the class character also. And it tells me the structure. It tells me it's a vector with 4 elements, and the values of the elements are 1, 2, 3, and NA. NA stands for not analytical. The other type of mode here is a logical. So I've created another vector C of length 3, and it takes on values true, true, and false. Okay. The class is logical, and if I type structure of C, it tells me it has 3 elements. The values are true, true, and false. Sometimes, so if I create a new vector by concatenating A and B, remember what A and B are. A, B. Remember, all elements must belong to the same mode and class. So here I have characters, and then I have numerics. So R will coerce them to belong to the same mode and class when I create this new guy, D. So you'll notice now D, it took 1, which was numeric, so it stacked the vectors A and B next to each other, but now it coerced them to all be characters. And now it's a vector of length 10, whose elements are characters taking on values 1, 2, 3, 4, 5, 3, 1, 2, 3, not analytical. Okay, so there is no way to use a vector that has some things that are some elements can't be numeric and others character, for example, or will coerce things to belong to the same mode and class. Okay, now let's talk about matrices. So matrices are rectangular arrays. They belong to the class now called matrix. All elements, again, must have the same mode. So here's the pseudocode to create a matrix. I'll use this guy, matrix. That's my function. I'll input my data here. This could be a vector, but it doesn't have to be. I can list the elements on the fly. And I have to, at the minimum, tell it the number of rows. Or you should, at the minimum, tell it the number of rows. By default, it will create a matrix with one column, and we'll see that in a moment. How would I refer to the, once I've created a matrix, the ith, so the data in the ith row and the jth column, so experimental unit I, for example, jth variable, what's that value? I would type my matrix I, comma, j in brackets. And then once you've created your matrix, then you'll apply functions to the matrix, just like you would any other object. Okay, so again, the first step is to read the help file if you want to understand more about matrix. So it'll tell you the basic arguments. You have to input some data, and it'll tell you, specify the number of rows, specify the number of columns, and then by row equals false. That means by default, it will enter the data in the first column, then move over to the second column instead of entering by the first row, second row, and so on. And you can name the rows and columns also using div names. So let's jump in. Here's my vector A. If I want to turn that into a matrix, by default, it will turn it into a matrix with one column, okay, and 6 rows. So notice it took the numbers 1, 2, 3, 4, 5, 3, and then stacked them as now a 6x1 matrix. I didn't save that to my workspace, but what happens if I do this? Now I run the code matrix of A. It's going to use the same elements, 1, 2, 3, 4, 5, 3. I told it that I should create a matrix with 3 rows, so R will be smart enough to say, okay, well I have 6 elements, that must mean I need 2 columns. It will do that math for you. It's enough to give it the elements, and either the rows or columns. R can figure out the rest. You'll notice it stacked 1, 2, 3. It filled the first column first, then went over to the second column. Now if you run mode of A, this is numeric. The class of A is it's a matrix. So if you run structure of A, you'll see that this is a 3x2 matrix. The elements are 1, 2, 3, 4, 5, 3. So it'll tell you that A has 3 rows, 2 columns. Okay. How would I pick off? What's this going to do? A of 2, 3, it's going to get the element in the second row, and this is going to be an error message because I don't have a third column. If I do A of 2, 2, here's A up here. Second row, second column, that number is 5. What if I create this matrix? What am I changing here? So remember, this is how A was created. Let's create a matrix B. What does this do? The only difference here is that now I'm saying input the data by row first. So what's B going to do? What's B look like? 1, 2, 3, 4, 5, 3. So now it's stacked the data. It filled the first row, then the second row, then the third row, and so on. Now, if I run mean of B, it might not give me the mean that you would hope it would give you. It's going to compute the mean of all 6 elements rather than column means or row means. We'll see how to do that later. But now that B is saved as a matrix, if you run something like plot, it will plot the points. Okay. Here's 1, 2. It plotted that point. 3, 4 up here. Plotted that point, and it plotted 5, 3. 5, 3. It's right here. Okay. And again, there's the mode, class, and structure of B, just like A. The elements are in a little bit different order. If I run summary of B, we'll learn more about this function later, but what did this do? It summarized what it thinks is variable 1. So what is B again? 135. So it got a summary of the numbers 1, 3, 5, first variable. Okay, then it got some summary statistics of the numbers 2, 4, and 3. Specifically, it got the minimum, the first quartile, the median, the mean, the third quartile, and the max. And it does that for each column. Now, a matrix does not have to be numeric. So here, the elements of this matrix C are true, true, false, false. And I told it 2 rows. If I see what's the mode of C, it's logical. The class of C is a matrix. So now you're starting to understand the difference between the mode and the class. So the mode refers to the elements, the storage mode of the elements. If I run mean of C, you'll notice that actually it did something, even though C is a matrix of true and falses. What it actually does here, if you read the help file of mean, you'll find that it will take a true and assign it value 1, and a false and assign it value 0, and then compute the mean if you try to apply the mean function to a logical. If you apply the summary function, it says the first column, it summarizes that I had 2 trues. The second column, it summarizes that I had 2 falses. Okay, so let's talk about names and how we would name our columns and name our rows. So I'm going to create a vector called column names for exam 1, R names for the names of my rows. So my units are going to be Sam, Max, and Billy Bob. They took 2 exams, let's say. And I'm going to create a matrix called exam scores, 80, 90, 95, 70, 75, 99. These are my scores. I'm telling it the number of columns is 2. And notice I hit enter. And R is still, because I have a comma here and it hasn't got this last parentheses, it will wait until I'm done running until it sees the last parentheses. Okay, so I can I don't have to run one long line of code. This will do the same thing as if I had ran this code. So if the line of code gets too long, you can just hit enter, and you don't have to run everything in one line. All right, so here are my exam scores. Sam got an 80 on exam 1, Max got a 90 on exam 1, Billy Bob got a 99 on exam 2, for example. What would I do to refer to the second row, first column? So what is that? Second row, first column, that's Max's exam 1 score. That's 90. And indeed, that's what that did. What if I just type exam scores of 2? It's just going to get the exam scores for the second row. So this is how I refer to Max's data, 90 and 75. What if I wanted to look at exam 1 scores? Comma 1 says go get all of the data in the first column. So Sam got an 80, Max got a 90, and Billy Bob got a 95. If I wanted to change Sam's second exam score to a 0, I can overwrite individual elements like this. So exam scores, first row, second column, change that number to a 0 and save it as exam scores. If I apply mean of exam scores, summary of exam scores, same thing as before. Remember, mean does the mean of all 6 exam scores, though you would probably want the mean of either the rows or the columns. If you run summary of exam scores, it will summarize exam 1 and exam 2. It will summarize the columns. So, for example, the median exam 1 score was a 90. You can verify that that's true. And the mean exam 1 score was a 88.33. You can verify that too. Okay. Another way to create a matrix is with this function. So suppose I had my exam 1 scores and I had my exam 2 scores, but I didn't enter them directly as a matrix. You can guess what the cbind function does, and again, you should read the help file. It binds them. It binds them as columns. So cbind stands for cbind, or column bind, excuse me. So exam 1 and exam 2, and it also retained the names exam 1, exam 2. If I wanted to assign row names to my exam 1 scores, so now I no longer have my row names, I would do it like this. This says go get the row names of exam scores and assign them values Sam, Max, and Billy Bob. Now I have exam scores matrix with row names and column names. All right, last but not least, we have arrays. So some notes, arrays are similar to matrices, but they can have 3+ dimensions. Actually, they can have 1 dimension, 2 dimension, 3 dimensions, 4 dimensions, however many you want. So these are even more highly structured type data. They belong to the class array, just as a matrix belongs to the class matrix. And all elements, again, must have the same mode. So that means every element in an array must be a logical character or numerical. So here's how you create an array. You use the function array. Input your data, it can be a vector. Tell it the dimensions. So a matrix must have 2 dimensions. Now you have to say, do I want 3 or 4 or 5? And then you can tell it the dimension names. So we'll focus on a 3-dimensional array. So here's how you will refer to the elements. This will get, for the first dimension, it will get the ith element and the jth second dimension, jth element for the second dimension, the kth element for the third dimension. So for example, if you had cubical data that is shaped like a cube, this would be useful. So then you'll apply a function to your array. And a lot of 3D plotting asks for arrays. All right, the first thing to do is read the help file. So I'll let you read this a little more carefully on your own. But you'll notice you have to input the data. You have to tell it the dimensions. It will give each element of the data its own dimension if you don't specify, and then you have to tell it the dim names. Well, you don't have to tell it the dim names. And it will give you, again, if you scroll down, it'll give you some examples. I also want to point out, now that we're getting a little more familiar with functions, sometimes as you get better and you have a good idea of what a function is doing, you don't need to read the whole help file. You really just want to know what are the arguments for input. So if you just do args of array, that will go tell you what are the arguments. All right, let's create an array of the letters of the alphabet. So for my first dimension, my names are going to be A1, A2. Second dimension, my names are going to be B1, B2, B3. Third dimension, C1, C2, C3, C4. All right, so let's create our array. I have this letters vector that's already in saved as an object in R, so I can always just type letters and it goes and gets these letters. So let's create our array. So I'm going to create an array called alphabet that contains the letters of the alphabet. I'm telling it the dimensions are 2 by 3 by 4. And to enter the names, the dimension names, I have to have a list of this, this, and this. We'll learn more about lists in a little bit. For now, you can just know that you can just use this code. So here are the names of my first dimension, names of my second dimension, names of the third dimension. List them as dim1, dim2, dim3, separated by commas. And so what did this do? Here's what alphabet looks like. So here is the first element of the third dimension. So we have a 2 by 3 matrix, and we have 4 of those. So here's the 2 by 3. Here's the first 2 by 3 matrix. Here's the second 2 by 3 matrix. Here's the third 2 by 3 matrix. Here's the fourth 2 by 3 matrix. Okay. Let's look at the mode of alphabet. This is character. These are letters. What is the class? It's an array. So how would I just refer to, let's say, my first 2 by 3 matrix? I want to refer to this guy. I use alphabet, comma, comma, 1. And it goes off and gets the first matrix. This goes and gets the second matrix, third matrix, fourth matrix. What if I do alphabet, comma, comma, 5? There is no fifth matrix, so subscript out of bounds. What's this do? This gets the element, the first 3 by 4 matrix. Second 3 by 4 matrix. And how many of those? What if I wanted to get the second 3 by 4 matrix and then just pick off the first row? That's what this did. Second matrix, first row. Okay, so you can see you have to start thinking three-dimensionally to really use these effectively. So they can be a little bit tricky. Okay.